Have you ever pondered the aftermath if the asteroid that wiped out dinosaurs returned to Earth in our era? Picture this. 65 million years ago, a colossal asteroid about 6 miles wide hurtled through the cosmos and slammed into what's now the Yucatan Peninsula. This celestial intruder, known as the Chicxulub asteroid, unleashed an unimaginable force, equivalent to billions of nuclear bombs. The impact created a fiery shockwave that incinerated everything in its path, followed by a global winter that changed the Earth's climate drastically. The world as the dinosaurs knew it was over. The majority of life on Earth, including the mighty dinosaurs, couldn't survive this cataclysmic event, and thus a mass extinction ensued. Now fast forward to the present day, our advanced civilizations, our intricate technologies, our complex societies, how would they fare under the same catastrophic conditions? Let's delve into this thought experiment. Now let's imagine that this colossal asteroid is on a collision course with our planet once again. The asteroid enters the Earth's atmosphere, a sight that would surely send chills down anyone's spine. Now imagine this, a colossal chunk of rock and metal, roughly the size of a small city, hurtling towards us at unimaginable speeds. Upon entering the Earth's atmosphere, the asteroid would face extreme resistance, causing it to heat up dramatically. This is due to the phenomenon known as ram pressure, which is the pressure exerted on a body moving through a fluid medium. As the asteroid plummets through the sky, it would compress the air in front of it, creating a shockwave that would heat the air to temperatures hotter than the surface of the sun. The heat would be so intense that it would cause the exterior of the asteroid to vaporize, creating a glowing envelope of superheated gas around it. From the ground, the spectacle would be terrifying yet awe-inspiring. The asteroid would seem like a fiery ball streaking across the sky, leaving a trail of intense light in its wake. The brightness of the incoming asteroid would be so great that it could turn night into day, casting long, eerie shadows on the landscape. Despite the immense heat and pressure, the asteroid would not slow down significantly. The Earth's atmosphere is like a thin veil to such a massive object moving at such high speeds. The asteroid would maintain a large portion of its velocity as it descends through the atmosphere, heading relentlessly towards its inevitable impact with the Earth's surface. But what happens next? The moment of impact, the point where the asteroid's journey through space ends and the true horror begins for those of us on the ground. But we'll delve into that in the next scene. For now, let's take a moment to imagine the sight of this massive object falling from the sky, lighting up the world in an ominous glow. A sight that would be etched into the memory of every living being, a sight signaling the start of a cataclysm. This is just the beginning of our apocalypse. The moment of impact, a cataclysmic event that would be felt across the globe. In a blink, the asteroid collides with Earth, releasing a staggering amount of energy. To put it into perspective, the energy released is billions and billions of times greater than that of the most powerful nuclear bomb ever detonated. This energy is so immense that it vaporizes the asteroid and a large portion of the Earth's crust on impact, creating a crater over 100 miles wide and several miles deep. In the heart of the impact zone, temperatures skyrocket, reaching levels higher than the surface of the sun. These extreme temperatures cause a massive, instantaneous fireball, incinerating everything within hundreds of miles. There's no time for escape. The destruction is immediate and absolute, but the devastation doesn't stop at the impact site. The energy of the impact sends shock waves racing through the Earth's crust, causing a global earthquake of unprecedented magnitude. This isn't your typical earthquake. It's a seismic event on a scale that's hard to comprehend. The ground shakes violently everywhere, from the tallest mountains to the deepest oceans. Buildings topple, bridges collapse, and landslides occur worldwide. Meanwhile, the impact hurls an enormous amount of debris into the atmosphere. Chunks of rock, some as big as cities, are flung into space, only to fall back to Earth, causing secondary impacts and igniting fires across the globe. At the same time, the blast wave races across the surface of the Earth, flattening everything in its path. Even hundreds of miles away from the impact, the force of the blast is enough to level forests, shatter windows, and toss cars like toys. And let's not forget about the massive tsunami generated by the impact. If the asteroid strikes an ocean, the resulting wave could reach heights of several miles, causing further devastation along coastal areas. The impact alone would cause devastation on an unimaginable scale, but the worst is yet to come. In the wake of the impact, the world as we know it would change dramatically. Our planet would be subjected to an almost inconceivable level of devastation. The immediate impact and subsequent shock waves would be just the beginning. What follows would be a series of catastrophic events that could potentially lead to the end of most life on Earth. The colossal amount of debris launched into the atmosphere by the impact would block out the sun, plunging the Earth into what is known as a nuclear winter. With the sun's light obscured, temperatures would plummet globally. This sudden and drastic drop in temperature would cause the planet's surface to freeze, making survival for most creatures extremely difficult. But the darkness and cold are merely the first stages of this apocalyptic scenario. The enormous volume of dust and soot in the atmosphere would also lead to acid rain. This corrosive precipitation would poison the oceans, decimating marine life and further disrupting the food chain. The acid rain would also contaminate freshwater sources, making it nearly impossible for remaining life forms to find drinkable water. With sunlight blocked, photosynthesis would cease. Plants, the fundamental base of most food chains, would die off, causing a domino effect that would lead to the extinction of many species. Herbivores would starve without plant life to sustain them, and subsequently carnivores would perish without their prey. Amidst this chaos, what would become of human civilization? Our technological advances might offer a glimmer of hope, but the challenges would be immense. Power sources would dwindle as the sun's rays, a primary source of renewable energy, become a rarity. The freezing temperatures would render most farming efforts futile, leading to severe food shortages. Moreover, the scarcity of resources would likely incite conflict among survivors, adding a man-made catastrophe to the already dire situation. The social structures and systems we've built could crumble under the strain. However, it's also possible that such a cataclysmic event could foster unprecedented cooperation. Faced with a common enemy, the remnants of humanity might band together, pooling resources and knowledge in a desperate bid for survival. Survivors might seek refuge underground to escape the harsh surface conditions. Subterranean living could become the new norm, with humans developing innovative ways to grow food and generate power in this new dark world. Despite the grim circumstances, the human spirit is resilient. We have demonstrated time and again our capacity to adapt and persevere in the face of adversity. It would be a test of our resolve, our ingenuity, and our ability to come together as a species. But make no mistake, the aftermath of such an asteroid impact would be a world far removed from the one we know today. A world where every day is a fight for survival, where every decision could mean the difference between life and death. The world would be plunged into a new age of darkness and struggle. Such a catastrophic event presents a stark reminder of our vulnerability as a species. Imagine, a rock from space large enough to wipe out most life on Earth, and we wouldn't even see it coming until it's too late. It's an alarming thought, isn't it? That's why the importance of asteroid detection can't be overstated. Scientists worldwide are working tirelessly to scan the skies for potentially hazardous asteroids. Using advanced technology, they're able to track these celestial bodies, calculate their trajectories, and determine if they pose a threat to our planet. However, detecting a threatening asteroid is just the first step. The real challenge lies in what we do once we've identified an incoming danger. That's where deflection strategies come into play. These are methods designed to alter an asteroid's course, preventing it from colliding with Earth. One such strategy is the kinetic impactor technique, which involves sending a spacecraft to collide with the asteroid, thereby changing its path. Another approach is the gravity tractor method, where a spacecraft uses its gravitational pull to slowly steer the asteroid off its collision course. Of course, these techniques are still in their early stages of development, and much research is needed. However, the potential they hold is immense. They could be our last line of defense against a cataclysmic event, a shield against the cosmic threats that lurk in the vastness of space. Every day we're making strides in these fields. We're improving our detection capabilities, refining our deflection methods, and learning more about asteroids and their behavior. It's a race against time, but one that we're fully committed to. In the grand scheme of things, we're just a small blue dot in the universe, vulnerable to its whims. But the knowledge we gain, the technologies we develop, and the precautions we take could be the key to our survival. While this scenario is purely hypothetical, it underscores the importance of our continued exploration of the cosmos and our efforts to protect our planet.